Hi, I'm Rob from the Industrial Edge Computing Business Unit of Dialog Semiconductor. In this video, I will show you how to use the Smart Server IoT Starter Kit example files to provision the LON devices included in the starter kit. To follow along, you'll need to have the Smart Server IoT GitHub repository on your PC. The Smart Server IoT Support Software Tools video explains how to clone the Git repository. Out of the box, your Smart Server is set up to be able to do this exercise. If you have previously done training exercises with the Smart Server, you may need to reset the Smart Server databases to start from a fresh point to follow this example. In your browser, connect to the Smart Server, log in, select the System tab, click the Reset to Defaults, and enter the Apollo password in these fields and click Update. Do not leave or refresh the browser page until you see this message after about 3 minutes. Connect to the Smart Server CMS and log into the CMS as user Apollo. Our work in the Smart Server CMS will focus on the device type widget, device widget, and the data point browser widgets. Let's get started. The device type package collects interface files, definition files, and resource files that define device elements used to build your networks. It may have a compound .dtp.zip extension or just a DTP extension. The DTP file is really just a zip archive of files used to define the device types. Another video in this series describes how to build DTP files. These files are key accelerators for integration. Typically, a senior team member creates these files and shares them with the other members of the team. You should have the Smart Server IoT Git repository cloned to your PC if you followed the previous video. To recap, the izot/Smart Server IoT GitHub repository contains the example files that are used to support the documentation. If you want to make sure your local copy is up to date, open a command box and use this git command. We are going to log in directly to the Smart Server CMS as user Apollo, using the password that is marked on the side of the Smart Server. Our work in the CMS will focus on these widgets. The device type widget is what we begin with. In the device type widget, use the Create Device Type action in the banner widget to create device types based on individual interface files. You can also use the Import Device Type action to load a package that contains all the files necessary to define your device types in the CMS. This action could require several minutes to complete depending on the number of device types and complexity of their interfaces. The blue pop-up notifications keep us informed as to the progress of the import. Here is the result we expect when the Lon Channel.dtp.zip package is imported. Here is a power tip for users. If your company builds systems with common device types, you can store the packages in this directory on your Smart Server. This way, whenever you do an Apollo reset of databases, these files will be loaded automatically. Here are the starter kit LON devices. Each includes a barcode of their unique ID that is needed when you define the device in the system. You can record the UID values for manual entry when you create the devices, or you could use the guided discovery method when the devices are created. In the CMS device widget, use the Create Device action button to add the EVB6050 device running the multi-sensor application. I'm naming the device MS1. It is an edge device, and I will not assign a context at this time. Click Next to continue the definition. We need to assign ownership of the device to the Smart Server IoT and to select the device type that was created when we imported the device type package earlier. For LON devices, the UID is a 6-byte hex value that if you have it available, you can enter it manually when you create the device. If left empty and selecting the guided discovery method, you can automatically fill the value when the service pin is pressed on the device. We click Save and we are done. We repeat the process for the SC100MP device. At this point, the Lon devices are defined but not provisioned. The immediate visual cue of this fact is the blue outline around the device icon. Provision the devices by selecting the device icons and selecting Provision Selected Edge Devices from the Device Widget Action menu. Your Lon devices must be connected to the FT channel for this to work. There will be a healthy amount of TX/RX activity on the U60 during the Lon device provisioning. This could span tens of seconds per device. Device types that are defined to have their application loaded over the network will take considerably longer to provision. When completed, the perimeter ring of the device icon will change from blue to green. If I select the device action menu, I can test the device to confirm communication use the wink action to identify devices if they support a wink behavior. I can also use this action to view and modify data points on the device using the Data Point Browser widget. In this short video, we have learned how to import a prepared device type package for the defined devices in the Lon channels of the starter kit. Using the device widget, we have defined and provisioned the Lon devices. The device widget was used to test and verify communication to the devices, and finally, the Data Point Browser widget was used to inspect the data and control the device. This pattern is similar for all channel types supported by the Smart Server IoT. In other videos, we will walk through the process for Modbus RTU and BACnet devices. I hope you found this video useful. Thanks for watching.